Hey, Prachi, are you, you should do an audio test. People are just sort of leaving the room from the previous working group. They ran late.
Okay. Can you hear me?
Absolutely perfectly.
Awesome.
I'm getting sorted and connected to the Meet Echo here.
All right.
Why don't you start sharing the slides? Unless you want me to do that.
Yeah, you might have to do that, Leaf. I'm getting some kind of error.
All right. We are trying to get organized. Where the hell is the slide sharing thing?
Yeah, I see a screen share. I
Yeah,
somehow.
I know. It's just there's supposed to be a I see the problem. The slides are um they're not yeah, they're hang on. I think there is a I don't know, the file name doesn't end with that .pdf, and I think the Meet Echo doesn't recognize the
Oh,
the slides. I didn't know that that was a thing. All right. Let's see if I can just sort of share my that slide window, and I can just do that. All right. I think at least then we can start doing this. Where's the down? All right. This is like in lieu of proper slide sharing. All right, I'm gonna do this while, and that at least gets us started. So, Prachi, why don't you
yeah,
take it away?
sure. All right, everyone. Welcome to Tigress at IETF115. Um, Apologies for the technical difficulties we're having. Um, Next slide, please. All right, the note well, as it's said in Outland, knows the note well. So I'm sure you all are pretty aware of it. It's almost last day of IETF, second last day. Yeah. This session is being recorded, just a few disclaimers. And then if you are an in-person participant, please make sure to sign into the session using the QR code. And if you're remote, make sure your audio and video is off unless you are sharing or presenting. And please use the raise hand tool when you have questions. The resources are all linked here, the agenda, the media information, and how to report any issues. Next slide. So the agenda for today is pretty brief until we're going to hand it over to the authors. We're going to walk through all the draft updates they have made. They have taken all the feedback they received from 114 and over the mailing list, and we'll just go over through some of the updates they have made. and then we can move on to the questions phase. A couple things which I wanted to know, we do have an unfortunate conflict with sec dispatch today, so hence the low attendance. And then one more administrative thing, when you come up to the mic, please identify yourself. It helps the note takers and everybody else in the room and on Meet Echo. Do we have a note taker for today? Is there anybody who would like to volunteer?
I see Ulle kindly volunteering. So yes, we have a note taker. You're going to do it in the thing, the tool, right? Yeah, that's perfect.
Thank
All right.
you. All right.
Yeah. All right. I switched slides over to let's see if I can just do that, and we can. I think that's okay, right? All right. Well, I think we're good to go. Yes.
Okay, well, hi everyone. First of all, thank you so much for coming out to our working group meeting. I know it's late on the second to last day, and so we definitely appreciate your participation. So this is the working group meeting for TIGRESS, which stands for Transfer of Digital Credentials Securely. Next slide, please.
There is a lag, unfortunately.
Got it, no problem. Okay, so today I have three presenters. My name is Casey Asses, and I'll be presenting with Brandon Leventhal and Dmitry Vinokurov. But we also have some additional authors, and a lot of them should be on the call as well. But that's the full list. We'll be representing Apple, Alphabet, as well as Mercedes-Benz. Next slide. Okay, so today's agenda, we're going to do a quick overview of the problem statement. We went over this a little bit more in depth in IETF 114, but for those that didn't join, we just wanted to go over that. For the majority of the time, we want to talk through our requirements. So this is additional documentation that we've done in the last 3 months, and then overall talk about what the next steps for the working group are. So with that, we have the problem statement. So in today's world, there are lots of different ways to add digital credentials to your device and walk around, especially with access to hotels, cars, home, etc. And while there has been some solutions for sharing within a single UI platform or maybe within a certain type of credential, right now there is no widely accepted way of transferring a digital credential securely between digital wallets of different software and hardware manufacturers. So our main goal is to find a solution that works for all types of these digital credentials as well as, all platforms. So there are three main entities as part of this sharing process that are depicted above. We first have the sender device. This is the person that's originating the share, and they already have some sort of digital credential on their device. And then we have the receiver device. This is the person or device that we're trying to share to give that additional access. The sender device at the beginning already has some connection with the credential authority or provisioning partner. This is the entity that is in charge of maintaining the list of who has access to what, actually minting those credentials for each user, and just doing full life cycle of that pass. So the job of the provisioning partner in this situation is to give provisioning information down to the sender, and the sender needs to send that to their receiver. So the provisioning information, you can just think of it as a token that the credential authority sees and knows that it's okay to provision this on that device. So it's very high level, and we'll move on to the next slide.
And it's slow.
Yeah, no worries. So diving deep a little bit into the problem statement. So the digital credentials on your device and the hardware that you're actually interacting with in real life are owned by that provisioning partner. So in some situations, you can think of this as a hotel and the hotel owning the actual locks on the doors. Or you can think of this as you being the one that owns the locks on your home, for example. You are your own provisioning partner in that situation. So these provisioning partners need to keep track of these share networks that you might create, as well as the provisions associated with each user. So that could mean that you have shared to 3 or 4 different people, and each of the people might have different access rights or different entitlements associated. And that provisioning partner is meant to keep track of that so you can manage them at any moment. So these provisioning partners want to enable sharing provisioning information between a sender and receiver independent of the software and hardware manufacturer. So they also don't want to be keeping track of who has implemented what or making different unique solutions per manufacturer. So next slide. So just to go a little bit into a use case, let's talk about a hotel use case. So say I'm staying in a hotel. When I'm staying at this hotel, the hotel operator owns this property as well as the physical locks, like I was just saying. So during my visit, I'm actually only renting a room. I'm not the one that owns that. And so therefore, that's why the credentials owned by the hotel. So say that I've paid for 2 people to be able to access my room, and therefore I can add up to 2 keys for my room. Once I reserve the hotel room under my name, and therefore I can download or provision a digital hotel key on my device. However, I want to be able to share that with my partner or my spouse that's going to be joining me. So therefore, the hotel or the provisioning partner will provide me with the provisioning information required to give to my spouse so that they can then provision their own hotel key. So the nice part about this is a lot of hotels these days require you to make accounts with them, like a Hyatt account, for example, in order to provision or have access to their app. And so when you share to your receiver, they shouldn't have to have access to the app or create another account, etc. They should just have that provisioning information, and that should be sufficient to redeem and get that hotel key. Lastly, at the end of your stay, the provisioning partner will manage the key, delete it off your devices, and you're good to go. No stopping at the lobby. So now I'll be handing off to Dimitri to go through our requirements and start the discussion.
Thank you, Casey. Thank you for showing interest to our working group. Can we please?
Yes.
So in the previous IETF conference, we presented the solution, and there were questions, and the feedback that we received was we were trying to propose something without defining formal requirements. We decided to step back, write a draft containing formal requirements to the solution, and another draft with sample implementation, threat modeling, and present it to the community during this conference. And right now, we're going to go over several slides which show assumptions that we made, and then requirements grouped into certain groups, like on the slides. Next slide, please. So the assumptions to the solution. We have some knowledge about the digital credentials. And based on that knowledge, we come here to ask for advice from community whether these assumptions and requirements look valid. We come here for help, basically. The first assumption is provisioning partner may not allow for 2 users to use the same credential or cryptographic key material. This assumption is based on the fact many of the digital credential providers, they own the infrastructure, as Casey mentioned on her slides. They own it and they want to distinguish between 2 credentials with different entitlements, access rights, and even the time the credential can be used to access property. Second assumption, user may not have the ability to revoke a credential that a provision partner has issued. Again, this assumption is based on the fact that the property is owned by a hotel chain or a private owner. And people who have access in their digital wallets to the property, they are just given a right to access temporarily or maybe for a longer time. third is user may have not ability to create new digital keys without provisioning partners interaction. So again, in order to receive an access to a hotel room, I first need to request property owner to issue a new credential. Security. Communication between sender and receiver and provisioning partner should be trusted. So obviously, when the new credential is issued, the channel needs to be trusted. The next is the choice of intermediary shall be defined by application initiating the credential transfer. So our solution proposes an intermediary server. We understand it's just one of the ways to approach this problem, and we specifically propose that intermediary server in our solution in order to achieve some goals. If I have a key in my wallet and I want to initiate a sharing process with my friend, I want to offload that provisioning information in encrypted format and store it temporarily for the time of the transfer. And that's what our intermediary server is intended for. And there should be certain level of trust between me as initiating the transfer and the intermediary server who temporarily stores the content. The next one is sender and receiver shall both be able to manage the shared credential at any point by communicating with the provisioning partner. Credential lifecycle management is out of scope for this proposal, which means the credential which I have in my wallet, in order to be managed, it needs to be managed by the provision partner. So let's say hotel chain that owns the rooms in the hotels and all the logs in the hotels. And I can only issue requests for them to change the access rights or maybe life cycle of the credential. And the final assumption is any device OEM with a digital credential implementation adherent to Tigress shall be able to receive shared provisioning information, whether or not they can originate provisioning information themselves or host their own intermediary. We want to separate the credential initiation and the credential provisioning. So if I receive a link from my friend, invite from my friend in form of URL to my device, I shall be able to provision that, accept the link, and provision a pass to my wallet. And basically, that's it. Separation between initiation by sender and provisioning by the recipient. Next slide, please. And now we go to the requirements. So there was a lengthy process discussing this in both private GitHub repository and on a mailing group with both co-authors and all people interested in this work group. And as a result of that, we tried to formalize requirements to the solution that we propose. So I will read the groups of the requirements, and then if there are questions, we can discuss it either at the end or at the end of this slide. So first requirement says requirement connectivity. Sender and receiver devices shall be allowed to be online at different times. Both devices shall never need to be online at the same time. So simple example, I want to share a key to my home or to my car with my friend. So I initiate a share, I send them a URL which points to that temporary storage provisioning information, and my connectivity shall be limited just for that time. My friend may be offline at the time, but when they receive an SMS or email or encrypted message with that link, with that URL, they shall be able to provision that credential to their wallet, having connected to internet. At that time, the initiator, the sender, don't need to be online. The second requirement is solution should allow sender to send share invitation to receiver over any messaging channel with various degrees of security. So again, going back to our proposed solution, we temporarily store the provisioning information, the voucher, which allows our friend to provision that information to the wallet. We store that temporarily on intermediary server, and we can share the link pointing to that provisioning information with our friend over multiple channels, over a simple SMS, which has a limit of 140 characters, over email, WhatsApp, iMessage, or any other, maybe Signal protocol. The next requirement is P2P. So,
Oh, was that too soon?
it was this, but it's
Okay.
fine. I do remember.
We're
So P2P means that we are trying to focus, presenting this particular solution on person-to-person share process of credentials. So I want to share my credential with a single person. And the goal sharing, which means if I wanted to share it with multiple people at the same time, is not in focus for a given particular solution, even though we do not preclude that goal in the future. If there is any questions to this particular group of requirements, please ask them. Otherwise, we can move on to the next group of requirements.
No. Keep going. Do you have a clarifying question, Ola? Otherwise, I think it's easier if we kind of, because we have a lot of slides, if we can just run through them, and then we can do interrupt for clarifying questions, and then we do kind of discussion at the end.
Appreciate it. All right. Transfer data. So first requirement is arbitrary format. Since there is multitude of different credential types, let's say some of them are digital car key. So it's a credential which allows you to operate your car, open it, start the engine, drive it, etc. Other types of credential can cover digital keys to your hotel room. Other types of credential can allow you to open an apartment door in a multifamily home, or maybe a private, a door in a private home. So all these may be regulated by different specifications. Some of them can be published as Car Connectivity Consortium. Some of them are proprietary to certain hotel chains. So we want our solution to try to approach and handle all these type of credentials to allow users to share them, to transfer these credentials from one person to another. The next requirement is round trips. Again, some of the credential types require multiple communications between two devices using intermediary server. For instance, in a car key wall, when I want to share a key to my car with my friend, I'm getting deeper into details now, but when I want to do that, the actual keys are generated on my friend's device, and then the friend will send back to me a key import request in order to be signed by me as a car owner. And then I need to sign that key import request and send it back to my friend. And only then friend can provision the new credential which was generated on their device. That's why for some protocols, we need multiple round trips between two. And the third requirement is preview. This is mostly for user experience, the better user experience. So as a friend, when I receive a URL to a shared credential, I want to be able to understand what I'm trying to provision to my wallet. Basically, that's it. I guess we can move on. Security and privacy. Security. A solution should provide security of the provisioning data transferred, confidentiality, integrity, and availability. Simply said, the provisioning data that we temporarily store on intermediary server needs to be secured. And I'm here making a reference to the security triangle. Second requirement is revocation. Solution shall maintain access control, allowing sender to revoke before the share has been accepted, and for receiver to end transfer at any time. Since sometimes transfer can include multiple steps, both sender and receiver shall be able to control and revoke, like cancel, sharing process at any step. We can move on, please.
Actually, we have somebody in the queue, and
Yeah.
maybe Michael. You.
Hi. Just the one that's on the slide there, requirement security. So confidential, integrity, and availability. Do you mean authentication? Seeing as that's bundled up with security.
Right. I'll get to there. Not purely authentication in the form we normally understand that. It's not strong authentication by any like digital certificates.
Okay. And is availability a security property? Would it not be better to have it as a separate requirement?
Right. So availability, normally it's a recommendation to implementer to provide, to implement some measures to guarantee availability of that intermediary server. If there is like DDoS attacks, measures against that.
Okay. Yeah, I would say have it as a separate requirement, but okay.
Of course. Now I'm moving to the requirements referring to our intermediary server. So again, our solution proposes a temporary storage in the form of intermediary server. So we often refer to that as a mailbox storage. So we create some temporary place, store that provisioning information in encrypted form in that temporary place. And both devices can use it to exchange that. So first requirement is privacy. An intermediary server shall not be able to correlate users between exchanges or create social graph. It shall never be an arbiter of identity. So it's a very strong requirement because we don't want our solution to collect information about user identity. Store that, sell it, use it in any form. And due to that, our requirement to authentication cannot use strong authentication. We cannot send user identity to that intermediary server because it can be collected. Second is requirement 95. So again, it's mostly for the ease of user experience. So in the use case when there is a multiple exchange like round trips between sender and the receiver devices, and whenever each device updates the content stored on intermediary server, we want push notification, some automatic notification to be sent to appropriate party in order to notify them to come and fetch an update. And the next requirement is opaque. So the message content, I'm referring to that provisioning information that we store temporarily on our intermediary server, shall be opaque to that server. So which means if I implement that intermediary server, I shall not be able to look into what's stored there or use it, let's say by provisioning a pass to someone else's digital wallet.
Dimitri, we have a question from Yaron.
Of course.
Yaron Sheffer. So first of all, privacy is mentioned in the draft, but very sparsely. There's only one requirement. And I would like to contrast two use cases that to me demonstrate that we need to think at least one level down, deeper into privacy. So in the case of car credentials, if I lend you my car for 2 hours, I don't want anybody to know about it. It's just between you and me. However, if in the case of a hotel room, it makes sense, and in fact, Casey mentioned that the hotel needs to know about it and needs to have the identity of the second person. So those are two very different use cases, and I don't see how they can coexist. Would appreciate that clarification.
Thank you for your question. It's a really good one, and we actually received that question in some forms previously. So the state is that currently access to a car using digital credential it has only one published standard, which comes from CCC body, and it defines how a digital credential can be used in order to provide access to the car. If there were other standards, let's say open standards, which would regulate those, we would be gladly and using them. Unfortunately, there is only one standard, and it requires communication to so-called vehicle OEM server. So simply put, I can do that exchange between two devices, generate a new credential, and add it to the wallet on the receiving device. But there is always that last step. So in order for that credential to work, the CCC requires a request to be sent to the vehicle OEM server in order to register that newly minted credential so that the car recognizes it. We tried to argue in one of the CCC meetings, and the answer was, since modern cars, especially those who implement that standard, they are very expensive assets. And car manufacturers, they don't want to carry responsibility for illegal access to the car.
So if you want your anonymous car, buy an old mechanical Ford. I guess that's the answer. Should we? But somebody was on the queue here. I'm seeing Alex.
Maybe just one more word. In that case, if that's a requirement, if you need to follow the CCC to be compliant with the CCC standard, and it to some degree contradicts at least the intention of other requirements, this needs to be pointed out as a requirement.
Yes, thank you. That's a very good comment. The only thing I want to mention is that this is a requirement for our particular solution. And our particular solution basically covers just the transfer part, and CCC defines the provisioning part. So once the credential is provisioned to the wallet, what are the next steps to start using that credential, right? So we have a key to the wallet, in the wallet. So how do I open the car with that new key? So there should be some exchange between the device and the car in order to let the device start to control the car. But it's a great question, and we realize the sensitivity of that matter. We do realize, again, if there is a standard, and if anyone is willing to start working on the standard, which would be, which would control the access to the car, we would be willing and glad to adopt that.
And I think, Dimitri, as you mentioned, this is Alex speaking, Alex Peltier. The distinction here is that this privacy requirement is for the intermediary, if there is one, and that it doesn't track it, but the provisioning partner credential authority always needs to know who is in control of the keys. So whether that is an on-device credential authority or a hotel, they need to know who is shared to who. And so there's not privacy in that sense. There's just privacy for the transfer protocol.
Thank you, Alex.
No matter what, this needs to be clarified. So people
Go to the microphone.
Yeah, sorry. This needs to be clarified so that people who read the protocol or the requirements understand the privacy implications. And by the way, I strongly disagree with Alex's latest statement. Whether the credential issuer needs to know of a certain delegation is per use case and not necessarily always.
Thank you very much. If you have time, we have that document published in GitHub, and at the end of the presentation, there is a link, all the URLs to the documents. If you could come and leave your feedback, or maybe in the mailing group, which is better probably, we would very much appreciate it.
I would suggest that you open an issue on this particular topic, so we don't forget to kind of clear it, and then we can address that later.
All right, continuation of our requirements. So again, this is about our intermediary server, and we want this intermediary server to implement some mechanisms to prevent abuse by share initiating device, verifying that the device is in good standing and the content generated by the sender device can be trusted by intermediary. The trust mechanism could be proprietary or publicly verifiable, for example, in form of web authentication. Simply put, we want to establish, since share initiation is the crucial part of the transfer process, we want to establish special trust mechanisms between sender device and intermediary server. Both of these need to start to trust each other. And the way we propose is by using attestation, not linked to the user identity. So whenever sending device creates a mailbox, the content can be covered by the attestation blob, which intermediary server can verify following defined rules and make a decision whether to trust the content or not. And the next requirement covers the receiving device. So for the case of receiving the device, the level of trust, the level of requirement is lower. So we don't want the receiver device to provide attestation or any strong authentication. We just wanted to trust a list of intermediary servers it can work with. So whenever I receive that URL to that temporary storage on the intermediary server, we only propose. So the receiving device has a allow list of intermediary servers. So recognized by device manufacturers. And if that intermediary server in the list, we make an assumption it can be trusted. Again, we're not enforcing strong authentication here because of the privacy requirement, which we covered before. And this concludes all the requirements.
We have Ollie in queue.
I was wondering about that list. You said that the device manufacturer manufactured the list in my device.
Mm-hmm.
Can I manage that list to make sure I control who I'm trust? Should I always only trust the manufacturer?
Good question. So when I say device, what I actually mean is a digital wallet, the application that manages credentials on your mobile device, right? And if someone implements that digital wallet, they have a control over what intermediary servers they can interact with and who can be included in that trusted list. And I believe it's the details of implementation. So it can be done by allowing users add new intermediary servers into that list, or it can be hard-coded or in some form programmed onto your application. So in the solution that we propose, we have a list of intermediary servers, which includes 1, 2, 3, 4, 5, right? And we as developers, as the owners of that digital wallet application, we make decision who we trust.
Well, in IETF, we develop protocols that can be implemented in many ways. And assuming that only you as a device owner is in control of that list. And for users using the protocol in another situation that you think shouldn't be able to manipulate and edit that list or add to that list. If I want to add an intermediary to my phone, I should be able to do that because that intermediary handles the credentials that I need and your list doesn't. So be careful here.
Thank you. That was a great question. Again, it's very sensitive matter. Let's say I want to develop my application and it's my responsibility to define the rules, the security rules my application is following when we interact with the user. I don't know if you agree or not with that.
So I'll go on the queue as an individual, and say that I mean in the EU wallet space, right? The EU is taking more or less the same approach as Apple does here. Right? So it's kind of up to the wallet application to define what its trust list is, and so I think the deployment model you're going to see is possibly multiple wallet applications. And that they will kind of vary with ecosystems. Yep. So I don't think there's not necessarily any like huge impact here, right, for user control, because there will be multiple ecosystems and multiple wallet app, and they will be used for different things. Yeah.
Thank you.
We've also talked about this kind of issue, I think in 114, we talked about potentially having a list of these existing intermediary servers. Maybe not in the actual solution spec, but maybe in an implementation guide. So for whatever ones that are considered accepted, or the working group would get to accept them and add it to the spec. But we can definitely talk about that more as we have more intermediary servers.
I'm just going to make an administrative decision to stop sharing because people can find the QR code and get on the speaker list.
Michael?
Hi, I just wanted to echo the other point made about users being able to add intermediaries if they want, that it shouldn't be something that apps unilaterally decide for their users. The other thing I wanted to raise was throughout the requirements, you stated if an intermediary is required for the solution, and I think you've demonstrated some case where it actually genuinely is required, and car manufacturers don't seem to want to delegate permissions to people who own things. And yeah, I think that says something about the way that ownership works nowadays. If the intermediary is required in some solutions, will it be possible to use this protocol without an intermediary? Does that make sense? I realize that an intermediary is sometimes required, but if that means that this protocol always means that an intermediary will be required, I think that's a step backwards.
Yeah, absolutely. So the intermediary is not necessarily required for the car key stuff. That's more of like communication with the car OEM is required. Yeah. In theory, like you could implement the intermediary on a device itself. So this could be extended to a place where it's just device-to-device communication. And if you had a car OEM that even supported, provisioning that or creating that key from the sending device, like in theory, you could do all of this offline without, having anyone or like any third party interact with you. I imagine that if you even took a step further and, you did it over like a protocol like Bluetooth or something, then you could do it, completely like just device to device in proximity.
Okay, thank you. I just wanted to check that wasn't being written out of the protocol. Thank you.
All right. Are there any other questions in the room? Remote?
Nobody
Okay,
seems to be running for the mic. No.
Okay. So I'll just ask the authors to kind of summarize the status of all the drafts you have currently so that everybody understands where we are. So Dimitri, Casey, anyone can.
Yeah, sure, no problem. So since at 114, we had a proposed solution draft that we voted on and then have worked on a little bit since. So now we have a requirements draft and a sample implementation and threat model draft that are all published at Data Tracker. So I'm really excited. We've gotten a lot of feedback on the requirements draft in the last couple of weeks from different members. I think a lot of them are probably in the security dispatch meeting, but that's in a much better spot than it was even a couple months ago. And the sample implementation is probably the newest, so definitely take a look at it if you have a moment. So yeah, that's the status. Then they're all obviously on GitHub, and the links are on our slide deck.
All right. So I think for the authors, we still have some feedback that we need to incorporate in the requirements draft. I think right before this email, we got some comment from Ecker as well. So the next steps would be for you all to go back and incorporate those feedbacks and publish a new version of the draft, requirements draft, and then we can probably do an adoption call. Does that sounds like path forward? Yeah. Leif, do you have anything to add to that?
Yeah, I think that's it kind of allows you to iterate a little bit quicker, right? We're getting a lot of feedback, and while the draft is kind of under your editorial control, it's kind of up to you how you process all of your own change requests basically on the document. But I think we're also getting to the point where it makes sense to kind of move it into the working group because that's kind of where we want them to be. But once we get to that point, we have to start getting consensus sort of in a different way, and the documents will by that nature move a little bit slower. Yeah. So I think for practical reasons, it actually helps if we see that there isn't a lot of contention on the list around the comments that is coming in. I don't think we're seeing that. I just think we're seeing like good content and good suggestions. You sort of incorporate those, and then we're at a point where, all right, let's fine tune the resulting document as a working group document.
Yeah. And one last piece I wanted to note that I don't think we mentioned this at 114, but we do have 2 parties that have implemented our solution, and we know it works, which is a good thing. And of course, we'd love to keep incorporating comments and tweaking it, but I think at least we have good proof of concepts, which is exciting. And I think that we've also had just some discussion in the working group email list and our Git about different solutions, and I think we were a little bit too fast to say that other solutions wouldn't work. I think it's true other solutions might have worked for this. And I think we were just looking for a nice straightforward way that it would work and that anyone would be able to implement. So I just wanted to add that and definitely acknowledge that because I feel like we weren't acknowledging that very well in our last meeting.
We should definitely think about running a hackathon session.
Yeah.
I don't know whether Yokohama is too soon, or I don't know what you think, Prachi, but
yeah, no, hackathon would be a great idea, I think. Yeah. And we can propose the idea. I mean, I'm sure we'll get good participation.
Yeah, I mean, if we can pull off a successful hackathon session at an IETF with like where we know that the relevant industries are present, that actually helps kind of move things along quite a lot.
I see Tommy in the queue.
That was your
hello. Yes, yeah, I was just having to wait for audio to kick in. I've been following this work both from a kind of IAB standpoint as well as a person at Apple. And a while ago, we did have a conversation with CCC about this and talking about the fact that there are these essentially early versions where we're testing interop now and may even, we can have deployment that works between the different things, but the protocol is expected to evolve based on the discussion in the working group. And even if we're looking at the direction that some people are pointing to, like, okay, maybe it's going to be a profile of WebDAV or something else. It could like take a very sharp turn as far as the implementation. And what I'm wondering when we're talking about hackathon or these early implementations is kind of like, do we have a strategy that's formalized for how we evolve from an early implementation and saying like, okay, the client, when it knows it's trying to share a credential or receive a credential, knows what version it's on. Like, oh, this is on the early proprietary version. How will those clients migrate to what it ends up being? And I think that answer could be different depending on, like, is it a tweak of what you're doing today, or is it a completely different protocol server you need to point to? And how do you recognize that you need to do that? So I just want to point out that we should consider that. And I'm curious to hear if you have thoughts already.
So I see Brad in the queue. Brad, are you trying to answer the question?
Yeah, I don't know if this is a great answer, but I think one of the takeaways we got from the quick experience is thinking about versioning early on in the protocol development allows you to make those like very sharp pivots. Maybe that's what you were trying to get at, Tommy, but I do think that's an area that we need to start thinking through as we start to move into the working group adopting these things, is having a very reliable versioning system so that we can keep the design space open.
Right, and Quick is a good example. I think it started with, there's an invariant of like, this is a packet over UDP, and like this first little bit will tell you the version, and that's the thing. I guess I'm asking, what is it in this case? Is it a URL that we get, and the URL that tells us where to point to as the intermediary, that is the thing that tells us the version, or is it something within the TLS connection, etc.?
Alex speaking. Currently, the share URL that's accepted has a version in there, and right now it's version 1. So if it was updated to be version 2, clients that supported version 2 could do radically different things. Really,
perfect.
Yeah, I'm gonna show my ignorance here, but my understanding of WebDAV is that it's an extension of HTTP. So I think that given the way it's set up now, like all of the other potential solutions that are being proposed would fit into the proprietary solution that is working right now.
Okay, so essentially we're assuming that everything bootstraps off of a URL that begins with https:// and there's something in it that can indicate the version. And I guess even if we decide, hey, this is SMTP, we could just have a different scheme in the URL and you could key off of that. So the URL is our negotiation mechanism here.
Yes.
Okay, great.
Yaron?
I'm probably missing something, but if the URL determines the version, doesn't that imply that you do need to have the intermediary server so that you have the URL?
Yeah, that's a good question. I think we'll need to think on that a bit. Yeah, especially if we want to have it be available to expand into like device-to-device communication or something like that, where you're not going to a server.
Maybe consider putting it into the credential format in some way.
Definitely.
Hi, this is Nick. I just want to comment on that as well. Proprietary solution does not need to use URLs at all if it doesn't want to go through the intermediary server. So that'll be just left up to just, the proprietary solution and its own versioning if it wants to negotiate that. So you could do it over, like nearby sharing or whatever, Bluetooth or UWB or whatever it is that you want to do.
All right, any other questions? from anyone?
We're
We are
almost out of time, yeah.
Yeah. All right, I think then we'll close it off. And thank you everyone for coming. We have some action items that we'll take from here, and we'll continue the discussion on the mailing list. Have a great IETF week. Thank you.
Thank you.